Understanding the building blocks of a video network. I've got one slide for this nugget, and this is it, because with that network diagram, I can talk about just about anything. So I'm sitting in the dental chair a couple days ago, surrounded by video, ironically, as we were talking about this video series, because they installed televisions in all the dental rooms, the dental seats. So I'm watching Netflix as they're picking away at my teeth. And they have this reality cooking show kind of thing on, to where essentially they bring in the top chefs of the nations and they give them these challenges. Like, I was watching one where they were doing a dessert, and they said, okay, you've got 30 minutes to build the most amazing dessert, and you have to use a graham cracker, a marshmallow, and honey, or I mean, they're just random things, and they would take 30 and put together these things, and the judges would judge, and anyway, it's called Chopped was the name of the show. It was very interesting. So you're a top network engineer of the world, and you have to build a video network. What are your ingredients? Well, let's start off with the biggest ingredient, the endpoints, what the end user sees. First thing you can have is a desktop video endpoint. Anytime you think desktop video and you're talking Cisco, think Jabber. That's what this little icon here is meant to represent. The Jabber client can be installed on Windows, on Mac, on iPhone, Android, iPad, everything that's out there that has a screen. And the beauty of it is it ties right into the corporate system. It can tie into the video communication server, or VCS, that Cisco has, or CUCM. We'll talk about those in just a second when I talk about call control. But it makes that endpoint, that desktop, part of the video experience, right? And you can start video calls from that. When you're thinking about conference calling and you're thinking of Cisco, think about immersive telepresence. That's the new buzzword, immersive telepresence. Essentially, you have three screens. It's very commonly, matter of fact, I think I pulled a picture up of this. Three screens right here that are all HD. You've got HD cameras, and essentially you typically will have a conference room coming around. Now, these three people could be all in a different part of the world. They could be in three different parts of the world, but they've come together to join this conference room, and a lot of great stuff can happen. There's just something, I know a lot of you may disagree with me on this, but there's something that happens with video that's interactive right there. I mean, it's kind of like when I'm going to have a business meeting, and it's a big one, I'll usually go to do it in person. I don't have access to an immersive telepresence room like this, although I wish I did. But there's just something that happens when you're there and you're face to face and you can see emotion that you just don't get over a conference call with the Polycom system sitting around. It may not be in person, but by golly, it's as close as you can get without spending thousands of dollars to get all these people out here for a conference call. And you can have it right then with no travel required. So that's what we're talking about when we're talking about conference. Streaming can be done in a couple ways. Streaming essentially means delivering that video stream to the endpoint, and that the streaming endpoint could be real-time player, could be Windows Media Player, could be QuickTime, VLC, could be HTML5. HTML5 has built-in capability to handle video. Whatever it is, you can have either on-demand or continuous loop streaming. So you could say, show me the video collection of the CEO's company announcements for the last month, and you could go say, okay, I want that one, and it plays that's on demand. Or you could have continual streaming. Actually, I've got a church app on my iPhone for Elevation Church, and they have this thing where you can get essentially the past messages on demand, or you can just go to the streaming where they have a webcast that's always going all the time, playing random different messages all across the system. So you can choose which one you want. The beauty is when you go to a streaming format, you can convert the thing to multicast. And with multicast, Multicast. You can send one stream that reaches many as long as the network is set up for it. Now, multicasting across the internet typically doesn't work well. Even multicasting within an enterprise, unless you have some very intentional network folks doing it, you have to set the network up to support multicast, which most people don't. But if you do, you can get some amazing bandwidth savings because you're sending one stream to many clients. Video surveillance, dropping off of the largest one. Video surveillance is where you can equip your campus with a number of different video cameras, allowing you to see what's going on. Requires that you have some kind of live console or a console to take all these streams and put them together, or a recording station. We can start combining surveillance with a lot of the analytics that you can do to identify events that are occurring on the network. More on that in a second. Call control. This is a big one. So essentially you can have all these video endpoints, but you have to have a system to rule them all. And that's the call control. That's where we need something like CUCM or Cisco VCS. So VCS, Video Communication Server, or CUCM, that you can see here on the screen. Cisco Unified Communication Manager. VCS is the call control entity that is focused on video alone. The name gives it away. Video Communication Server. It is designed to do just video. The beauty of it is you can use it to extend your video outside of your organization to a website where you can have customer service calls using video, or to other organizations that go outside of your own control, your own boundaries. Whereas CUCM, this guy right here, is designed to focus on internal, your own enterprise. Controls IP phones, can also set up video conferences. Essentially, this is the control. So we ask the question, what's it controlling? Well, you don't want to have to go to all these endpoints and equip them with the knowledge of your enterprise one by one by one. So you have to have something that manages, for instance, dialing or dial plan, or sets up the features, or sets up, for instance, a ring group that rings multiple phones at the same time, or that controls, are you allowed to make this call? Is there enough bandwidth available? That's the kind of control that we're looking at. So when you're thinking about call control, think about dialing. For instance, if we had this guy connected to the public switch telephone network, the essentially voice network of the world at large today, we'd have to start thinking about things like E.164 dialing. E164 dialing means essentially the phone plan of the world. When you pick up your phone, I'm in the United States, I pick up and I dial area code 480-555-1212. That number has to adhere to a standard. I can't just make up random numbers or have different lengths of numbers. There's a standard. That's E164. Worldwide standard for phone numbers is the best way to think of it. Maybe you're using URI dialing, and that's related to the SIP protocol. URI being the Uniform Resource Identifier, essentially is the new way to do addressing, which looks just like an email address. That's what they did with SIP, is say, okay, well, we're going to do addressing like, let's just say this Jabber endpoint is actually Jeremy at cbtnuggets.com. And by using the same kind of standard, you can follow the same kind of method with DNS to find and locate those people. So that might be something you have to set up. So essentially, you have to have a plan. That's the whole big picture of that call control entity, is you have to implement that plan, whether it be E164, whether it be URIs, whether it be an internal extension range, like where I say Phoenix is 1XX extensions. You know, we're going to use 3-digit numbers. Australia will be 2XX, and then Detroit will be 3XX. And I then number all my phones accordingly and inform my organization this is how we're rolling this number system out. And then already have a game plan when my company grows to 10 different locations to update this thing to maybe 4-digit dialing. And that brings us down here to gateways. Gateways can be one of two different types. You can essentially have TDM gateways, or I'll just call them cube or IP to IP gateways. So let me talk about each one of these. TDM, time division multiplexing, is the language of love for the old world. Essentially, when you have your voice over IP or video network and you want to take that outside of the system of IP as we know it, that's typically a TDM style network, right? They call it time division multiplexing because that's typically how you handle a bulk digital line like a PRI connection or BRI ISDN connection, because there are video endpoints for ISDN. You don't see them many places, but you might need to interface with those, maybe, and that's the kind of gateway that can convert you from the new world of IP to the old world of TDM. Cube is a gateway that bridges between two different IP-based networks. Now, I'm looking at this diagram, and we're just kind of assuming, right, that this is all one company, Phoenix, Australia, and Detroit coming together. But what if it's not? What if the Phoenix office right here is partnered together with this organization in Detroit and Australia, but they're not the same company? Well, I don't want to make connections from my internal enterprise systems to these outside entities which I don't fully trust. They're a partner organization. I don't like opening holes in the firewall to give access to my enterprise servers. And again, these are my enterprise servers. Welcome to Cube. Cisco Unified Border Element is the essentially router that you can put that defines the border. So essentially these guys peer to Cube. Just put Cube up there. And Cube peers to your internal resources. We've got a publisher and a subscriber. Essentially, these are redundant, by the way, to where if this is the read-write copy of the database, goes down, this guy takes over and runs the whole network. Well, Cube keeps people from ever seeing those. Essentially, it acts as the broker on the edge. That's a gateway. Multi-point control unit. MCU didn't make the list because they're very specialized, but they do exist for handling conference calls. So MCUs essentially are the DJs. When you think of a DJ, and I'm kind of old school, you know, with the 5 different record players and whatever else, they're all mixing all these sound signals into a single stream, right? And that's what the multi-point control unit does as it relates to video. Essentially, you can have video in one of two ways. One, let's just say you've got a video call with 6 different people. You join them all together. You're likely going to need a mixer, a multi-point control unit, to where you're seeing all these different people. You can handle it to where you have one active speaker at a time. So whoever is loudest, whoever's talking, will have the floor. And so he's got the full motion video that's being fed to everybody. And everybody else freezes. Now that's cool, that works, and the benefit of the active speaker multi-point control unit is, or I should say configuration, is that it does not use anywhere near as many resources as a continuous video stream, to where all of these are active all the time. However, you can tell it's going to be a lot more natural, right? Somebody sneezes, they're the loudspeaker for the moment, the camera shifts over to them, and then it flips back to the active speaker, right? And the person kind of has like an exploding face because they are sneezing and the spray is going everywhere, and it freezes like that, and they're like, you know, trying to clear their throat to get the active speaker again, because everybody freezes at the point that they were last the loudest speakers. Now, obviously, there's things that you can do to prevent that, like adding a little delay in case there's a loud noise, a door slamming, something like that, from flipping over. But remember, anytime you add a delay for the loudest speaker, then you're not going to have it be as natural, because there may be, somebody starts talking and it doesn't flip over because they just had one sentence to say and people, who was that? Those kind of things. So typically you want to have all of them being active videos, but that's going to consume resources. Let me talk about those. They didn't make the list. DSPs, digital signal processors, essentially the little gems that you put inside of your MCU, or the multi-point processing power that essentially run the whole thing. These are specialized to process video, in the same way that you have a highly specialized video card in your computer, or when you're mining Bitcoin, you can buy ASICs, essentially application-specific integrated circuitry. These are hardware devices designed to do one thing, and that's mine Bitcoin, right? So they make hardware to do this, and that's what these DSPs are, specialized processors, so that you're able to have a whole bunch of active video streams at once. Typically, one of the more pricey items in your network. This one I kind of talked about a little bit early when I was talking up here with streaming, to where you can choose to have a live stream, like always going multicast or on-demand stream. I won't rehash all that. Transformation. Transformation may be needed for video streams as they're happening, and most of the time it goes right along with this live video stream. You may want to do something to it. For example, if you're streaming video, I go back to churches a lot, because churches are huge on streaming videos. Just go on your iPhone or Android and just search the store for streaming churches or something like that. They're all streaming different videos, and if you watch one of those, essentially you'll see they're as they're going, you're kind of seeing the light adjusting, as the person's walking around, because a lot of times, even if the stream is live, you can have people adjust the balance, the hue, the quality of that. You might have it pop up a tagline on the bottom of the screen, like, call this number, or here's the reference that this guy is talking about. So essentially you can get all of those things. That's all considered transformation, adding a little logo to the stream as it's happening, even if it's on demand or live. Anytime you're doing a transformation, whoop, you're right back up here. You're going to need DSPs, especially if you're doing it on the fly. I mean, on-demand processing, many of you I know have done video editing. Grab a Macintosh computer, makes it easy, right? Or even on your iPhone nowadays, edit video on the fly. It can do it using its own processor, because it's not needed on it's happening now kind of basis. It can run that process behind the scenes. But if you're doing it live, if you're doing it while you're streaming these things on the fly. Now, for example, let me just mention, as I finish recording this right now, I submitted to CBT Nuggets. They've got an engine that literally takes my video, churns it all up, and puts logos on it, puts it into different formats. I know a lot of you are listening to me on high speed. I don't know how you do that right now and process the information, but different speeds they put me in, and they're all essentially being rendered. Well, there's, again, resources behind the scenes that do all that. That's the DSPs. Video analytics. Video analytics, this is the building block that allows you to do pretty cool things with a video as it's happening. It typically will be combined with video surveillance or live stream, on demand stream, those kind of things. Essentially analyzing what's going on. For instance, you might have a video pan where it's going across the stadium, and you have an analytic device that is counting the number of people that are there, because it can actually distinguish from the video the differences between the different bodies that are there, or you can tell whether a person is smiling or frowning, or a simple one that almost every video system supports these days is motion detection. You can have surveillance going on that when it detects motion, that you define what motion means. You may have a constantly spinning ceiling fan, and you say, no, that's not motion. But if it's below this point of the video, bam, turn it on, start recording, take snapshots, whatever the case is typically seen with video. That's all considered analytics. I mean, and this gets really cool where you can have it, where my family homeschools, right? And so we kind of do weird things. And we went to this, a lot of weird things. So we went to a recycling plant, which if you've ever not had the chance to go there, do it. I know it sounds lame. It's totally cool. To where essentially, all the recycled garbage that you put in, they take it to this plant. Now, I don't know what it's like in your region. Maybe they are using video analytics, but essentially in my region in Arizona, essentially they've got a whole bunch of people that they've got these conveyor belts, and all this trash that is supposed to be recycling is going at lightning speeds, and these guys are machines. I mean, they've converted, I don't know how these people keep up with it, but they're literally like oh, off, on, off, nope, not recyclable. This goes in the trash. Oh, glass, no, aluminum, no, metal, no, and they're like sorting these things on the fly, like you would expect a mechanical arm to do. Now, I'm sure it's expensive to implement, but I mean, that's the kind of thing that analytics can do. Is instead of having these people here, you increase the conveyor belt speed 50 times or whatever level it can go at, put some mechanical arms there, and have the analytics look at the products as they're going through and make the determination: trash, recyclable, plastic. Now, again, there may be probably a lot more to that than anyway. You know what I'm talking about. That's analytics. Monitoring is a system that makes everything stay online. Obviously, these CUCM servers are valuable. Your cameras that are IP based are valuable. Even sometimes the video endpoints or telepresence conference systems that you have in place are valuable, and you can hook them up to monitoring, which almost always orbits around SNMP, Simple Network Management Protocol. Using a tool like PRTG or SolarWinds Orion or many of the other monitoring systems that's out there, you can get graphs, reports, statistics from all these devices. Beyond just uptime, is it online, you can also see how many active calls have happened, what bandwidth amount they're using. There's all kinds of stats that you can pull out of there. That is the elements that you have, your ingredients for success in building a video system. I hope this has been informative for you, and I'd like to thank you for viewing.